Prove statements about segments and angles. A proof. A proof is a logical argument that shows a statement is true. And a two-column proof has statements on one side and reasons on the other side. A theorem is a statement that can be proven. Usually from postulates. Okay, we're writing a two-column proof. Use a diagram to prove measure angle 1 equals measure angle 4. So remember, we need to start with our givens. And we can say that measure angle AXC equals measure angle AXD. And why can we say that? Because we have the little lines. No, we don't, do we? AXC equals AXD. We have that because it's up here in our statements. So, measure angle AXD. We can break that up into two angles, can't we? We can say that is angle 1 and angle 2 together. And the reason why we can say that is from the angle addition postulate. And then we can break up AXC into two angles. We can say 3 and 4. So now that we've said that, we can go back to statement 1, and we can say if AXC is 1 and 2, and AXD is 3 and 4, then 1 and 2 must equal 3 and 4. And that is the substitution. Because we have just substituted equal things into that statement. Now, 5. We can say the measure angle 2 equals the measure angle 3. And why can we say that? Because that is given. Okay, don't forget that second given statement up here. Now, if 2 equals 3, then I can substitute in, and go back to this step, we can substitute that for measure angle 3 here. Then, do you know what I can do? I can get rid of 3 on both sides with using the subtraction, and I am left with measure angle 1 equals measure angle 4, and that's what we wanted to prove. So we have proved it. Okay, theorem 2.1, congruence of segments. Segments congruence is reflexive, symmetric, and transitive. So for any segment AB, remember what reflection means? Like a mirror, you see yourself. AB equals, or is congruent to, segment AB. And then if AB is congruent to segment CD, then we can say CD is also congruent back to AB. And transitive, if AB is congruent to CD, and CD is congruent to EF, then AB is congruent to EF. And then congruence of angles. We can say the same thing with the angles. For any angle A, the angle A is congruent to itself. And then we can flip it. Angle B is congruent to angle A. And we can use a transitive property. Angle A is congruent to angle C. So example 2, name the properties. If 5 is congruent to 3, then 3 is congruent to 5. This is symmetric. Checkpoint. Give the reasons for this. Why can we say that those are true? Okay, start again when you're done with the checkpoints. If you know that ray BD bisects ABC, prove that the measure of ABC is 2 times the measure of 1. Okay, so what's our given? BD bisects ABC. So we are rewriting that statement here, and I'm just going to say given. Okay, so what does a real angle, what does it mean to bisect an angle? And it means that angle ABD is congruent to angle DBC. Now, what does congruent mean? Congruent means that the measure of angle 1, or ABD, is the measure of angle 2. So we're taking it from the shapes being congruent to the numbers linking up to them are also the same. Now, measure 1 plus measure 2 equals measure ABC. And that's the angle addition property, or postulate. Okay, now if we know that measure angle 2 is measure angle 1, then we can substitute in measure angle 1 for measure angle 2 using the substitution property. And then I can use the distributive property to go backwards and say that I really have 2 of measure angle 1. And then I proved it. The measure of angle ABC is 2 times the measure of angle 1. Okay, so concept summary. Writing a 2-column proof. Let's do another one. If AB is congruent to CD, prove that CD is congruent back to AB. So, first, what is that? How do we get this statement? We get it from its givens. Now, what can we say? We can say that AB equals CD, because that's what congruent means. Now I can flip it around and say that CD equals AB using the symmetric property. And then I can go ahead and say that means that the segment itself is congruent to AB. And then I'm going to give the reason why we can say that, because it's a definition of congruent segments. So in our proofs, we can use definitions, we can use postulates, or we can use other theorems that we've already proven for reasons. and givens. Solve a multi-step problem. There are two exits between rest areas on a stretch of interstate. The Rice exit is halfway between rest area A and Mason exit. So let's start drawing our diagram. So we have halfway. So put a point in the middle, and then let's label all our points. A, Mason, and then Rice. The distance between rest area B and the Mason exit is the same as the distance between rest area A and the Rice segment. So I'm kind of squishing this a little bit. Let's pretend that's the same measure and say B here. Now, let's mark that they're the same. The distance between rest area B and the Mason exit, so this one, is the same distance between rest area A and the Rice exit. Prove that the Mason exit is halfway between Rice and rest area B. So, write a proof. R is the midpoint of A to M. MB is AR. And why can we say that? Because that is the given. And that comes from right here. Now, what does being a midpoint mean? We can say that A to R is congruent to R to M. Definition of midpoint. And then we can also say that A to R then equals R to M, the measure of them, and that's what congruent segments mean. Now I can flip that around and say RM, or MB then, not flipping around. How do I get this statement? We can substitute, can't we? Or no, I'm even getting this wrong. It's transitive. Because if AR equals RM and MB equals AR, then MB must equal RM by the transitive. Okay, now what do we need to know? We need to know that the measure of MB segment is congruent to RM, because that's what congruent segments mean. And then therefore, M is the midpoint of RB, because that's the definition of a midpoint. Okay, go ahead and do your checkpoints. If you've never heard of a rumble strip, that's the bumps in the road that makes your car go boom, 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 boom when maybe you're coming up to a stop sign or something. And so draw that diagram out and see if you can answer number 3.